So let us talk about queues today. In the previous videos, we have seen what a stack is. Stack is a LIFO data structure, last in, first out, which means that the element that has been inserted last would be popped out first. Or in other words, the element that has been pushed last will be popped out first. Right here, we can take a stack. In a stack, one end is closed while another end is open. So here, I'll push 10 here. This will be the top of the stack. 20, 90, and minus 9. So here, the indexes are 0, 1, 2, and 3. If I want to pop out this element, I can pop out only 9 first here. After 9, I can pop out 90, then 20, and then 10. So what is happening here is that the element that has been inserted last, that is minus 9, is popped out first. That is why it is called last in, first out. The element that has been inserted last will be popped out first. Correct? I hope you are understanding this. Now let us look at what a queue is. Queue is a FIFO data structure, first in, first out data structure. For example, let us take a ATM here where we draw money from, right? ATM has always queues, right? So here people are standing in a queue. Here I just draw the maximum size. So let us assume that the maximum size of a queue is 4, right? So here is 0, 1, 2, and 3. Right, as you can clearly see, queue is open from the front and open from the rear here. So this is called a front of a queue, and this is called the rear of a queue. Correct? So now when the first person comes in, he comes in here, then the next person comes in, he comes into the line next to person 1, right? This person 2. So I am adding persons to the rear of the queue, right? So person 3 here, and then person 4 comes in here. So elements in a queue are added to the rear. Here in this example, in a queue where you have persons coming and standing in the queue for withdrawing money, first person 1 comes, and if the person 2 has to come, he cannot come before person 1, he has to come after person 1. So here person 2 comes in. So here we are adding persons. So persons are getting added to the rear of the queue, not to the front of the queue. Here person 3 is added again to the rear of the queue, and person 4 again is added to the rear of the queue. Now if person 1 has completed withdrawing his money, he goes out. So the first person that goes out of the queue is not person 4 but person 1. Right? So here person 1 first goes out, then person 2 goes out, then person 3 goes out, and then person 4 goes out. So here, as we can clearly observe, the first point is elements. Here we are saying persons, but generally elements are added to the rear, and elements are deleted from the front. Right? Elements are deleted from the front. Yes, as we can clearly see here. First, person 4 is not deleted, or person 4 doesn't go out. Person 1 first goes out, and then person 2 goes out, and then person. Therefore, addition or pushing from the rear and popping from the front. So here in queue we do not call it as push and pop. For push we use something called Enqueue, and for pop we use something called Dequeue. Correct? I hope you have got this clearly. Right? Now we have looked at real-time example. Now let us look at a dry run for how we would implement stack using C programming. Right? So I will just say introduction. I'll just say introduction to C program. Introduction to C program for queue. Right? So let us look at certain conditions as to what happens when we try to run a C program, and what are the conditions that we have to see to execute a C program perfectly. Right? So first of all, I will just draw a simple queue like I have drawn before. Right? So I will take only 3 elements for our sake. Right? It will be easy for you to understand. 0, 1, 2. So when I am saying 3 elements, these are nothing but 0, 0th element, first element and second element, right? Now initially the queue is empty. As we can see here, queue is absolutely empty. There are no elements in the queue. So we take 2 pointers here. We say front equal to -1 and rear equal to -1. When I say -1, it is pointing somewhere here, and this is also pointing somewhere here. So here, okay, I'll just, so this is also pointing somewhere where front is pointing now, correct? So now here, the reason I'm taking -1 is I'm just trying to say that front and rear are not pointing towards any index of the queue, right? That is my logic here. So front equal to -1 and rear equal to -1. So I can clearly say that if front equal to -1, then we can clearly say that, I'll say just printf pf, okay, this is printf, okay, I'm just writing a shorthand form, printf, queue is empty, queue is empty, queue is empty. Why is this condition necessary? Why is this condition necessary? Because whenever we are trying to dequeue elements from a queue, we need to check whether the queue is empty or not. What happens if we are trying to dequeue an element if from an empty queue? So we need to say that whenever we try to dequeue an element from an empty queue, we have to display some printf statement, printf to the, or print statement to the user saying that queue is empty, you cannot delete any more elements. So the condition for empty queue is nothing but if front equal to -1, queue is empty. Now suppose I want to add the first element, or I want to enqueue the first element into the queue. I want to enqueue, right? I want to enqueue the first element, suppose 10. I want to enqueue or insert the first element into the queue. What should I do? First thing I will do is, to enqueue the first element, I will say front plus plus here. When I say front plus plus, nothing but front equal to front plus 1, where front is -1 now. So -1 plus 1 is equal to 0. And I will also say rear equal to rear plus 1, where rear equal to -1. So -1 plus 1 is equal to 0. So now right hand side to left hand side, right hand side to left hand side. So front is 0 and rear is 0. So can I say like this? Can I say front is 0 and rear is 0, which means that front and rear both are pointing towards 0th index. So once front and rear are both pointing towards 0th index, I can just insert the element 10. So one understanding is that you just cannot insert an element and then point the pointer. You need to first point towards an index and then insert the element into the queue, right? So we have the first element inserted. So what is the second? I will just name this as first. What is the second condition, guys? Second condition is if front equal to -1, if front equal to -1 and rear equal to -1, then if you want to insert any element, then you have to make front as 0 and rear as 0. I'm just writing like this. In the program it will be a little different, but I'm just telling you that if you want to insert the first element in an empty queue, then this condition will happen. Of course, yes or no? Empty queue means front equal to -1 and rear equal to -1, and then you have to say you have to make front as 0 and rear as 0. Only then can you insert the first element inside. This is for empty, this is for first element. So our first element is inserted. What if you want to insert another element? Okay, again you have to call the enqueue function. Suppose I say 90. What should you do now? Simple. Just remain, let front remain 0 and increment rear. What do I mean by incrementing? Rear is 0 now, right? So can I say like this? Rear is 0 right now. Rear is 0. I can 0 plus 1, 0 plus 1. So rear plus plus. So rear will now become 1, which means that rear now will point towards 1, Rear now will point towards 1, and then once rear is pointing towards 1, I can just insert the element called 90. Now if I want to insert another element or I want to enqueue another element, simple, I just increment rear again. So rear was 1, so rear was 1, right? So I'll say rear plus plus. So rear is 1 right now, rear plus plus is nothing but rear is equal to rear plus 1. Rear is 1 right now, 1 plus 1, it becomes 2. Now rear becomes 2. Therefore the pointer now moves towards the second element, and then yeah, so I'll just say enqueue 5, and then 5 is inserted into the second element, right? Now please observe that front is 0 and rear is 2, right? Now if I want to enqueue another element, now if I want to enqueue, suppose I want to enqueue 290. Suppose I want to enqueue 290. Will I be able to enqueue? No. Why? Because the queue is full. So there should be another condition also saying that, if the queue is full, you should not be able to enter or insert any more element into the queue. So can I say like this? If rear equal to max minus 1. So what is rear here? 2. Equal to max minus 1. What is max? So what are the number of elements? 3, right? 1, 2, 3. So 3 minus 1 is nothing but 2. If rear equal to max minus 1, here 2 equal to 2, right? This is 2, right? 2 equal to 2. Then we say that printf, you just tell the user printf, queue is full, cannot enqueue, reject his demand of entering or enqueuing any more element into the queue, correct? So we have seen 3 conditions. First condition is if the queue is empty, you cannot pop out any more element. So this is the empty condition. Second condition is if you want to insert the first element and then make the front as 0 and rear as 0. So the third thing is if the queue is full, then reject any more demand to enter or enqueue any more elements into the queue. This is our third condition. Now if you want to delete an element here, delete. So delete is nothing but dequeue. I'll just say dequeue here, right? I'll just say dequeue. Suppose I want to dequeue. What will happen for a queue? From where are the elements dequeued? From the front. So how do I dequeue? Simple, it's very simple. I'll say here front equal to front plus 1 or front plus plus. So front is 0 now. So what will happen here? 0 plus 1 will become 1, right? 0 plus 1 will become 1. So front becomes now here 1, right? Which means that front is now pointing towards this first index. So what is happening here? When front points towards the first index, the pointer is moving from 0th index. Therefore this is now garbage collected, which means that 10 has been popped out, and now front is 1 and rear is 2, correct? Now if I want to dequeue another time, I will just say here dequeue, okay? Then what happens here? Again front is incremented, front is now 1, right? Front is now 1, therefore I'll do front is equal to front plus 1. So 1 plus 1 will become 2, which means that front now will point towards this element, second element. And now once front is moved to the right, the pointer is moving away from the first element, therefore this is dequeued automatically. This is dequeued automatically or popped out automatically. Now front and rear are both pointing towards the second element. Now you can also write this condition. So this is our fourth condition, where you can clearly say that if front equal to rear. So before going to if front equal to rear, suppose if I want to delete 5. What will I do? If I want to delete the last element or the element that is left. So you can also say that if front equal to rear. What do I mean by if front equal to rear? Which means that if front equal to rear, what does that mean? It means that there is only a single element left in the queue, right? So if you want to delete a single element left in a queue, you don't need to do front plus plus. You just say front equal to -1 and rear equal to -1, the pointer will move away from 2, right? The point, if you want to delete this 5, if you want to delete this 5, right? And how do you know that there is only a single element left in the queue? You cannot guess it, right? You have to check it. How do you check it? Using this condition. If front equal to rear, here front equal to 2 and rear is 2, is 2 equal to 2? Yes, true. Therefore, what will you do? You say front equal to -1 and rear equal to -1, right? And then what happens? The pointers move away. The pointers here move away, right? Here the pointers move away and front will become -1 and rear will become -1 and both will point towards this, right? And now they are not pointing towards the second element, therefore this is garbage collected and the queue is empty, right? Queue is empty. Now when the queue is empty, if you want to delete any more element, so what happens? Which condition is called? This one, right? If front equal to -1, then you say queue is empty, you cannot delete any more elements, right? So we have seen actually 4 conditions. First condition, the empty condition, where if you want to delete any element, you first need to check whether the queue is empty or not. If the queue is empty, then don't allow deletion. If the queue is not empty, then allow dequeue or deletion, right? Then comes the next condition, simple condition, where if you want to insert the first element, if the queue is empty and you want to insert the first element, then simply say front equal to 0 and rear equal to 0 and insert the first element, right? Then third condition is if the queue is full, then obviously you don't want the user to enter any more elements. So what will you do? Simply check this condition. If rear equal to max -1, then just don't allow the user to enter any more elements. Queue is full, cannot enqueue, right? And there is also one more condition. If you are deleting elements, one by one, you need to also check this condition where there is only a single element left in the queue. How will you do that? Just check if front equal to rear. If this condition holds true, it means that there is only a single element, and then if it is true, then say front equal to -1, rear equal to -1, which means that the pointer points towards -1 and -1, and it will not point towards the single element, which means that single element is garbage collected, right? As we have seen here, 5 was garbage collected, and then front was pointing towards -1 and rear was pointing towards -1. So in this example, we have inserted 3 elements, deleted 3 elements, and we have seen the empty condition. We have also seen the full condition. We have also seen a condition where there was a single element and how we deleted that single element. Yeah, so all these conditions we have seen. So once, because you have listened to this video, the next video would be implementation of queue using C. That would be much easier, right? Thank you for watching. If you have any doubts, you can comment in the comment section. Bye bye.